In this sample, we're going to calculate the period of a comet's orbit by using data from Earth's orbit and then data from the comet's orbit as well. So we're going to use Kepler's third law, but we're going to use it in ratio form, where we say the ratio of the squares of the periods are equal to the ratio of the square of the semi-major axes. So let me say this again. We've got, let me make that a more obvious E. The period squared of the Earth divided by the period squared of the comet equal to the cube of the semi-major axis of Earth divided by the cube of the semi-major axis for the comet. So some data, all right? Well, Earth's period is 1 year, and we can use that. That's just the unit of time that we'll use for this problem, okay? Now, the average distance of Earth from the sun, by definition, is 1 astronomical unit. And another way of thinking of the semi-major axis, since the orbits are so nearly circular, we can just use the average distance from the sun. So we can use that data from Earth. Now, in order to find the semi-major axis of the comet, we have to do a little bit of math because comets' orbits will be very elliptical, and there's a big difference between their distance at aphelion and at perihelion. And as we talked, we can find that by doing 1/2 the longest distance plus the shortest distance. And so they say when it's closest to the sun, it's 1/2 AU. When it's furthest at aphelion, it's 17.5. So when we add those and divide by 2, we get 9 astronomical units. So there is that. So now we can use Kepler's third law here to solve fairly easily for the period of the comet. So I almost always cross multiply first. TE cubed, squared. TE squared, AC cubed equals TC squared times AE cubed. Now I'm looking for the period of the comet, so I can divide that out. TE squared AC cubed divided by AE cubed. All right, lots of mumbling around there. So we have Earth's period is 1 year, and we're going to square that. The average distance for the comet is 9 AU, and we're going to cube that. And then the average distance for Earth is 1 AU, and we're going to Q that, although it doesn't matter. So what we get here is 1 times 9 cubed divided by 1, so the math's not too difficult, 729. And then we have years squared. Take the square root of that, and we get a period of 27 years. So that's one way we can calculate the period of these comets if we have the other information. Quite honestly, the period is something that's going to be easier to measure, so then we could back out its average distance as well. But this is sample 11-5. You'll have some more practice using Kepler's laws in the problem set for 7-5. Good luck.